Hello and welcome to Dr. T's Math. In this video we're going to look at systems of equations, graphically how to use the TI in order to find solutions. And so I've got a couple of different equations. One is a cubic polynomial here, the other is a linear equation. Press graph and we get these two. Now you'll have to fiddle around with a zoom window by pressing window on the TI and then probably reducing your y minimum to something like -15, y maximum to something like 0, so you get that center there. And then on the TI handheld, you're going to be able to find the intersection, you're going to be able to find the minimum and maximum, and then the roots of these equations, but you have to do it with a few other commands. And so you press second trace on the TI handheld, and number 2 is going to be the 0. You'll have to sort of triangulate the position by having a left bound and a right bound. So just to the left of the 0, just to the right of the 0. And then the minimum and maximum, number 3 and number 4, similarly you're going to have to say what's the left boundary and what's the right boundary. And then likewise with the intersection, but you can certainly find all these 3 things with a little bit more work, a few more keystrokes. And so on this one, like some TI models, you can just press right here on the graph and it's going to tell you the minimum maximum. The intersections are also known as the solutions. That's where these two functions equal one another. And then we can also plot that first derivative right there fairly easily. Now if you don't have this much functionality on your handheld, you can do the same thing in y equals by going down to another line and pressing math. And we're in math menu number 6 and derivative. And we're just going to type in that first function there, x cubed, arrow over minus x squared, arrow over minus 2x, minus 8. And where it says x equals blank, you just press S. You're just going to press x equals x. Go back to the graph, and there it is right there. Now if I highlighted this one on my application here and said d dx is going to give me the second derivative, and so the app here is a little bit more user-friendly, has more options, but we can find those first and second derivatives graphically fairly easily. Now on the TI you can also find that numerically or symbolically. Like number 8 here in the math menu, d dx, we're just going to press, just going to find x cubed minus x squared minus 2x, that same polynomial. And all you'd have to do is apply the power rule here. It's not a very complicated derivative to find, but maybe you just want to check your answer. We would drop down that 3 from x cubed and reduce the exponent by 1 to apply the power rule, so 3x squared, and then drop down that 2 exponent on the second term into the front, make it a coefficient, reduce the exponent by 1, so we get minus 2x, and then reduce the exponent on the third term. Exponent is actually 1, so x to the first minus 1 would be x to the 0. X to the 0 is going to be a whole number, which is how we get the 2. And indeed we have to say d dx. And then on the TI you can also find those values at a specific location on the graph. So for example, when we have our inflection points here, right, those you can see that's kind of that's lines up with the extrema, negative 1/3, or sorry, positive 1/3 on the x, negative 2 and 1/3 on the y. Going back to this one here, we have negative 1/3 on the x for the inflection point there. That lines up with the first derivative trough. So where the slope is 0 on the first derivative, we have an inflection point. And so if we wanted to figure that out numerically, we'll go math, and then the nth derivative. And we've got x cubed minus x squared minus 2x minus 8, and that was where x equals 1/3, and so remember alpha y equals will let us input in fractions, and we got 1/3, and indeed we get -2 and 1/3, and then back on the graph, -2 and 1/3 is the trough or the extrema here on our first derivative. And so there are many different functionality of functions and operations that you can use the TI for in order to figure out what's going on with functions graphically, algebraically, and in tables also. Right. This has been Dr. T's Math. Thanks for watching.